observed dewdrops on leaves on a cold winter morning, or snow melting on mountains, or water being boiled at home to make a bowl of hot soup? All these changes involve a change in the state of matter. But what causes these changes? You already know that particles of solid vibrate, those of liquid slide past one another, and gas particles bounce about freely. This indicates that solids have the least energy whereas gases have the maximum energy. So maybe if we can modify the energy of the particles, we can also change their state. Let's see this through an activity. Here we have ice cubes and a thermometer fitted to a beaker. Let's start heating this beaker. When we start heating, the particles absorb heat energy. This increases the temperature. To get a clear picture of how the temperature is changing over time, let's plot a graph. Here you see that as time passes, temperature of ice increases. In other words, heat energy supplied is sufficient to overcome the forces of attraction between the particles of ice. This goes to such an extent that ice starts converting into liquid water, which we now call melting. The temperature at which ice melts to water is 0 degrees Celsius. This is the melting point of water. This is indicated by point A. In general, at atmospheric pressure, the temperature at which a solid starts melting to a liquid is called the melting point of the solid. Atmospheric pressure is nothing but a constant pressure of air on all objects. Okay, now even as heat is being continuously absorbed here, we observe that the temperature no longer changes. Strange, right? Where does this additional heat go? Don't be shocked. This is no magic trick. This additional heat energy is simply converting ice to water at its melting point. Note that this happens without changing its temperature. This heat is called latent heat, as indicated by a straight line AB. You will be surprised to know that the word latent also means hidden in Latin. Apt, isn't it? Here, the latent heat is associated with the melting of a solid. Melting is also called fusion, and hence this latent heat is called latent heat of fusion. Now, once the ice melts completely, any further heat energy supplied can only increase the temperature of water. At this point, there is no ice left to change the state. This is indicated by a straight line that rises up starting from B. All this while, as the temperature rises, particles of water start moving even more rapidly and the liquid starts boiling. We again find that temperature becomes constant at C. This fixed temperature at which liquid boils at atmospheric pressure is called the boiling point. For water, the boiling point is 100 degrees Celsius. Upon reaching the boiling point, heat is simply consumed to change the state of water without changing the temperature, as is indicated by this line CD in the graph. This again corresponds to latent heat. Since this heat is absorbed in vaporizing a liquid, it is called the latent heat of vaporization. Now, when the last drop of water changes to vapor, the heat supplied only causes the temperature of the vapor to rise, going all the way up from point D in the graph. As you can see from the graph, there is no further change in the state of the vapor. Cool. Now that you know what happens when a solid melts and a liquid boils, can we also say that these processes are reversible?
Of course they are. The reverse of vaporization is condensation, and that of melting is freezing. Hey, have you also come across instances where solid substances simply vanish into thin air? But this is for another time. We'll learn about them soon. But for now, Let's quickly recap what we've learned.
The state of matter can be changed by bringing about a change in the energy of the particles. Air exerts a constant pressure on objects around it. This is called the atmospheric pressure. The temperature at which a solid converts to a liquid at atmospheric pressure is called the melting point of the solid. The temperature at which a liquid boils at atmospheric pressure is called the boiling point of the liquid. Latent heat can be defined as the energy absorbed when a substance changes its state. Latent heat is absorbed when the temperature of a substance becomes constant. The heat required to melt a solid when the temperature becomes constant is called the latent heat of fusion. And the heat required to vaporize a liquid when the temperature becomes constant is called the latent heat of vaporization.